A square prism, side of base 30 mm, axis height 50 mm, is resting on its base on HP. So it is resting on its base on HP, and its one of the rectangular face is 30-degree inclined to VP. So let's say this is XY line. This solid is resting on its base on HP. So shape of its base is going to be visible in a top view. And when you are drawing projections of solids, you are supposed to start the solution where you are going to get true shape of base of the solid. So in this case, the solution is going to begin with the top view. So in top view, we are going to draw a square. Now while drawing that square, there is one condition. One of the rectangular face is 30-degree inclined to VP. Now when you draw top view of that square prism is going to have two identical squares at the top and bottom. Okay, so there is one square at the top, one square at the bottom, and when you look at that solid from the top, those two corners are going to be overlapped at one corner, those two at single place, those two at the single place, and those two at the back end will be overlapped at the fourth corner. So that way this straight line is going to be one of the rectangular face. This line is going to represent another rectangular face. There is going to be one rectangular face represented by this line, and similarly by this line. Okay, so while drawing square in a top view, we need to draw one of the side of that square 30-degree inclined to VP. So what I'll do, I'll draw one line incline at 30-degree, and on that 30-degree incline line, let's construct a square of a dimension. What is the given dimension? 30 mm side. So let's say this is the square 30 by 30. Now when you have drawn this top view, there are two faces, one at the top, one at the bottom. So let's say you provided names to this top face ABCD and 1 2 3 4 to this bottom face. Okay, so for every corner we need to provide two names. One sequence ABCD and another one is 1 2 3 4. Now once you draw that square, then project it for the front view. What is the height of solid? 50 mm. So at a height of 50 mm, this is the outermost line, this is outermost line, and this one is bottom face. So these edges are going to be visible one. I'm just trying to highlight that edge. Okay, now when you draw a front view and you try to draw another view, that is top view, observer position is going to be above the object, and you are supposed to look at the object from the top direction. Whereas if you draw top view first, the observer position will be over here, and we are supposed to look at the object in this direction of the arrow. So when you look at the object in this direction of the arrow, this 4D, this line is going to be visible. So let's draw that with continuous thick line, whereas this 2B is going to fall on the rear end of the solid, and it is going to be invisible. So that line to be drawn with hidden line. Okay, and then provide the nomenclature. This is A dash, B dash, C dash, D dash, and this is 1 dash, 2 dash, 3 dash, and 4 dash. Okay, so finally provide dimensions. Base side is given, so provide that dimension 30, and axis height is given, so provide
It's 2 o'clock.
that dimension also, and that is going to be 50. So this is the solution for the given question. Next example, a pentagonal prism side of base 25 mm, axis 50 mm long, resting on one of its base sides on HP. So this time object is a pentagonal prism. So it is going to have pentagon at the top, pentagon at the bottom, okay, there is one pentagon at the top. This is top surface, this is base of the solid. It is going to have those rectangular faces, and two rectangular faces will meet each other, forming an edge. So when you look at that solid in any direction, some of the edges are going to be visible, some of the edges are going to be invisible. Now this solid has got a pentagonal base, and it is resting on one of the side of its pentagonal base on HP. So it is resting on this side on the HP. It is not completely resting on its base, it is resting on edge of that base, such that a rectangular face containing that side is 45-degree inclined to HP. What is the additional condition? Let's say this is the side on which it is resting on HP. A rectangular face containing that edge. So obviously one of the base edge and one of the top edge are going to be connected together, forming a rectangular face. This is pentagonal prism, so it has got such 5 rectangular faces surrounding that solid, and the edge which is in HP, a rectangular face containing that edge, so that rectangular face I have highlighted with the blue shade. This face is inclined at 45-degree to HP. So they have given axis inclination with HP, but in some different words. We know that if I draw axis of the solid, axis is nothing but I will locate center of its bottom face, center of the top face, and I will draw a center line. So this center line is going to parallel to all the edges of the solid. Okay, all the edges of the solid, and by default it will be parallel to all the rectangular faces also. So if one of the face is making 45 degree to HP, it means its axis is also going to make same inclination 45 degree with HP. Okay, they have given that inclination in other wording also, or base is 45 degree inclined to HP. That is quite obvious. If you make this face, rectangular face, inclined 45 degree, this face and its base, those two are going to be right angle to each other, perpendicular to each other. So if one of the line you are going to make 45 degree inclined to HP, the other line is also going to be 45 degree inclined to HP, and axis is parallel to VP. So when you are going to provide that inclination with HP, the axis is going to remain parallel to vertical plane. So let's draw the solution of this example. The solid, when you are going to draw solution for the projection of solids, this example is the axis of solid is inclined to one of the reference plane, and it is still parallel to other reference plane. So it is inclined to only one reference plane. So when you are solving example, when axis of solid is inclined to one reference plane and parallel to other, the solution is going to take two steps. The previous example, where axis was perpendicular to one of the reference plane, we got solution in single step. But here we are going to draw two steps, whereas when axis is inclined to both the planes, the solution is going to have three steps. So this example, we are going to draw two steps. The first step is called as basic view, and second step is called as axis inclination. Now to draw basic view, in case of projection of solids, what we are supposed to do, identify the resting reference. Either it will be resting on that reference on that specific plane, might be HP or VP, or that reference will be parallel to reference plane, either HP or VP. So for this example, the resting reference is this side, and this side is in HP. So we have identified the resting reference. Resting reference is side, it is resting in HP. So resting reference is in HP. While drawing basic view, we need to make that solid completely rest in HP. As it was resting on one of the feature in HP, we need to make it completely rest in HP, so that its base will be in HP. So when you make it rest in HP on its base, the true shape of its base will be visible in HP, and in HP nothing but in top view. Okay, so this example, the solution is going to start from the top view, because in that view we are going to get the true shape of its base. In the last example, I already mentioned that in case of projection of solid, always start with a view where you get the true shape of its base. So in top view we are going to draw a pentagon. Now while drawing that pentagon, additionally what we need to do, the resting reference that you have identified, this side is the resting reference. This side is to be kept at the right hand side. In projection of plane, we used to keep that resting reference towards the left. In case of projection of solid, we are going to keep it at the right. So when you keep it at the right, so the first step is going to be side at the right hand side. Length of side is 25 mm, and then complete the remaining pentagon. So let's say this is the pentagon that you have got. Now provide the nomenclature, as it is going to be overlapping of top as well as bottom face. For every corner we need to provide two names. Next, project it for the front view. The height of solid is 50 mm, axis length is 50 mm, so add 50 mm from the XY line. Draw the top face and complete this view. Okay, this side is on HP itself. Okay, and now when you look at this solid in this direction, this edge will appear over here. There is another edge, this B2 at the back end, but that is going to be overlapped with the E5 which is visible one. So we are going to give precedence to the visible line only. Then provide the nomenclature A dash, B dash, C dash, D dash, E dash, 1 dash, 2 dash, 3 dash, 4 dash and 5 dash. Okay, so this is the basic view. Now in a second step, the resting reference is this side that we have drawn at the rightmost end. This side in front view, it has become this 3 dash 4 dash point. So this point need to be kept on XY always, because it is resting on that edge on HP. So at some random distance, first locate this point 3 dash 4 dash. From this 3 dash 4 dash, the axis or that rectangular face is inclined at 45 degree. So from here I will draw one line incline at 45 degree. The line is inclined at 45 degree. If this line is inclined at 45 degree, its base is also going to be inclined at 45 degree. That is also given in the question. And complete the view. So this is going to be okay. Then look at this intermediate line also. Provide the nomenclature A dash, B dash, C dash, D dash, E dash, 1 dash, 2 dash, 3 dash, 4 dash and 5 dash. Okay, so this is step number 1, step number 2, step number 3. Just we have changed the orientation of the view without changing its dimensions. Now finally project it for the top view. Project every single corner point. Okay, now connect the intersection points. This is 1 1, this is 2 1, this is 3 1, this is 4 1, this is 5 1. Similarly A1, B1, C1, D1 and E1. I have changed nomenclature over here because this is also top view, this is also top view, but those two are having different shape, size and dimensions, so both cannot have the same nomenclature. Whereas in front view those two are having exactly same dimensions, so nomenclature of the first front view we have taken same nomenclature for the second front view also. Now when you connect this view, we have certain rules to follow. Let me erase this part. There are certain rules to follow. What are those rules? Okay, rule number 1. From every single corner, now in this case all the points that we have located over here, all are the corner points. So from every single corner point there has to be at least 3 lines starting. So at every corner there should always meet minimum 3 number of lines. There could be more than 3, but minimum 3 has to be there. Second, all the outermost lines are to be connected with visible line. Now what is mean by outermost line? So if you look at those points and if you try to connect them, now in this basic solid, if you measure the number of edges, there is a pentagon at the bottom, so number of edges 5. There is pentagon at the top, number of edges 5, and a vertical edge connecting one of the corner at the top and one of the corner at the bottom, so there are going to be 5 vertical edges. So there are total 15 edges. Okay, so we need to draw 15 lines in this top view. Okay, so the outermost lines, what are those lines? Let's say, as I mentioned earlier, if you have drawn front view and you are going to draw top view, we are supposed to look at the object in the top direction and draw the top view. So if you look at this second front view in the direction of arrow, this ABCD is going to be a visible pentagon, whereas this 1 2 3 4 5, some portion of that pentagon is going to be visible and some portion is going to be invisible. So let's say one ABCD is completely visible, so I will connect that pentagon first with all the visible lines. Okay, and now in case of that 1 2 3 4 5 pentagon, the outermost lines are going to be visible. According to rule number 2, I need to connect 2 with this B because 2B is one of the edge of the solid. Similarly, 5E is also another edge of the solid. You can refer to this view that you have drawn. E is connected to 5, 2 is connected to B. Similarly, 4 is connected to D, C is connected to 3. Okay, so those two are the outermost line. Similarly, this 1 2 and 1 5 are the another two outermost lines. So outermost lines we have drawn with continuous thick line. Now rule number 3, at any corner, if there are two existing dotted lines or hidden lines, the third line starting from that corner is going to be a hidden line. Okay, Now in case of this 1 2 3 4 5 pentagon, we have drawn outermost line visible in nature. Remaining three lines are going to be dotted one or hidden lines. So those three I will draw first with dotted lines. Now according to rule number 3, if you look at the corner number 3, 2 3 and 3 4 is a dotted line. So third line starting from that corner, which is going to connect it with the point C1, is going to be hidden line. Similarly at the corner, two existing lines are dotted, so the third line starting from that corner is going to be a dotted line. Rule number 4, for any internal corner. Now what is mean by internal corner? This 1 2 B C D E and 5, these are corners on the boundary line of the solid. The corner which are inside that boundary line, that is corner 3 4 and A, these corners are considered to be internal corner. So if there is an internal corner, and for that internal corner if there are two existing visible lines, the third line starting from that corner is going to be visible. So if you look at the corner A, AB and AE is visible line, so the third line starting from that corner is going to be visible line. Okay. And last rule number 5, if there are two lines crossing each other. Now what is mean by crossing? Crossing means if you look at this 3 4 and 1A, 3 1 4 1 and 1 1 A1, those two lines are crossing each other over here, right? But there isn't any corner. So crossing means when two lines cross each other and there isn't existing corner, then that scenario is to be considered as crossing of two lines. So if there is crossing of two lines, then out of those two lines, one of the line is going to be visible, whereas other one is going to be invisible. Two visible lines never cross each other, and two hidden lines never cross each other. Okay, so this rule already we have satisfied over here. This 3 4 is a dotted line, and another crossing line 1 1 A1 is a visible line. So that rule you can see over here. Okay, so this is going to be the solution. Okay, this is next example. In this example, the axis of the solid is inclined to both HP and VP. So as I mentioned earlier, this solution is going to be having 3 steps. So I have chosen one example which is similar till the step number 2, and just third step is going to be added to this same solution. So let's go through the question. A pentagonal prism, side 25 mm, side of the base, axis 50, resting on one of its base sides on HP. Everything is same. Now what they have given, the side which is in HP, that same side is 45 degree inclined to VP. Now if you consider that resting side as this side, okay, so that side is perpendicular to XY. In basic view we have drawn it perpendicular to XY. The same side 3 dash 4 dash, that has we have drawn over here, and that side is this is the side. This side is still perpendicular to XY line. Perpendicular to XY means it is still perpendicular to VP. Now we need to make this side 45-degree inclined to VP. So we'll have to draw one line which is inclined at 45-degree, and on this 45-degree line we need to locate that side 3141. The side that we have drawn over here, this side we need to redraw incline at 45-degree to VP, that is 45-degree to XY, and then complete the remaining view as it is. So the same view we need to redraw. These two are the dotted lines. There is one corner over here, one corner over here, one over here, and one over here. So these two are visible lines, these two are visible, these two are outermost lines, these two are outermost lines, so visible. These two are dotted line, these two are dotted line, and this is visible line, and this is also visible line, and it is connected to this corner 1 1. This is actually dotted line, but for understanding I have drawn it first. So nomenclature is 1 1 2 1 3 1 4 1. We already have located. This is 5 1. Similarly, this is A1, B1, C1, D1, and E1. So this was the step number 4. This is step number 5. Similar to step number 2 to 3 transition, we simply need to redraw the same sketch at different orientation. In case of step number 4 to 5 also, we are going to redraw the same object over here once again at different orientation. So as I have drawn it without scale, it is a freehand sketch, so it appears to be slightly different than the view number 4, but ideally those two are supposed to be identical to each other. Let me extend this XY line. Okay, now project all the points for the front view. Have I projected all the points? Okay, some points are being overlapped. When you draw it with a scale, they might not be overlapping each other. So when you draw it with a scale, you refer your own projections. Okay, let's connect the point now. This is 1 from here, 1 from here, so this is going to be 1 1 dash, this is going to be 2 1 dash, this is going to be 3 1 dash, 4 1 dash, and 5 1 dash. Similarly, this is A1 dash, this is B1 dash. I am taking projections from top view and front view and referring those intersection points. So this is C1 dash, this is D1 dash, and where is point E? Yes, at the center. This is E1 dash. Okay. Now when you draw this top view, first look at the object in a direction of the arrow and decide the visibility of the edges. Now this 1 2 3 4 5 pentagon is going to be near to the observer, so consider it as visible one, whereas this ABCDE is away from observer, so consider some portion of that pentagon visible and some portion is invisible. So near one visible, away from observer, some portion is going to be invisible. So this 1 2 3 4 5 is visible, so this is 1 2, this is 2 3, this is 3 4, this is 4 5, and this is 5 1. So that pentagon we have drawn with visible lines. Now then go to the our rules. Rule number 2, all the outermost lines are going to be visible. So this 2B visible, BA visible, AE visible, ED visible, and D is connected with this 4, so that is also going to be visible. Now remaining lines of that ABCDE pentagon are going to be invisible. So those two lines are invisible. Now apply the rules. Rule number 3, at corner C1 dash we have got two existing hidden lines, so the third line starting from that corner is going to be hidden, whereas at corner 1 1 and 5 1 we have got two visible lines. The third line starting from that corner is going to be visible. In this example, the step number 1 is going to be a basic view. Step number 2 is going to be axis inclination, and step number 3 is going to be other inclination. Here other inclination is inclination of the base side that we have considered in the step number 3. So whenever you are going to draw a solution on projections of solids, we are going to stick to this rule. First basic view, step number 2 axis inclination, and third step is going to be other inclination. Okay, so this is going to be our solution.